translational motion. Very often these words will be there. Translational motion, that one, translational, that one. So I think in very loosely I use this word in center of mass. So here the object, any arbitrary shaped object, and there's a point A. And after some time, what we see, the same object will be getting displaced here. Look at this particular displacement of point A and B. Displacement of point A and B is equal here, no? So this particular motion, I'm just taking this, you can be a rod, it can be a plate, it can be a pen, eraser, notebook, bag, any object. So let it undergo displacement like this. And I'll call this particular object as rigid body, because the chapter name itself is rigid body mechanics. What do you mean by rigid body? Under application of force, the distance between any 2 points during motion will not change. What do you mean by elastic? If you apply force, the body will undergo deformation, and on removal of force, it will retain its original shape. There's a elastic. What do you mean by plastic? Under action of external force, the body will undergo deformation. On removal of deforming force, it will retain some deformation. That is the meaning of plastic. What do you mean rigid? It will not undergo any displacement. A good example, like you take like an iron slab or thick iron rod. Of course, it can undergo deformation under large force of that one. Basically, rigid body is an ideal situation. So near rigid bodies is what when practical will take example, but theoretically what when rigid body is an ideal. Practically what when we never get any body which will not undergo deformation. It must undergo deformation, but certain range of forces the body will not undergo deformation. Then we can treat that as rigid body. So what is a rigid body? Under action of deforming force, the distance between any 2 points will not change. That's the meaning of a rigid body here. So I'll put it here. I applied a force, F1, F2, and there's a distance between 2 points. So what happens? X remains constant. You increase force, decrease force, whatever you do, that one, the distance between any 2 points and direction of force will remain constant. That is a rigid body here. It's a very idealized thing. Practically, we don't have anything called like a rigid body. Such a rigid body I'm taking here. So the body will undergo displacement. I'm just going to move. This particular motion is what I'll call translatory motion here. So further, we will so let me choose 2 points. This is B. Let this be. The position of vector of this will be RB and RA. And then the position vector, let this be equal to RB A bar. So can you go for subtraction of vectors? Using RA bar, RBA bar, what you can write? RBA bar. Already I think from subtraction of vectors, I'm writing the direction of RBA bar, not RAB bar. It should be RBA bar, that one. We should write in this particular way. And then what is RB bar minus RA bar? We are going to write RBA bar. So as the object starts moving, so it is having translatory motion. It is having translatory motion. Body having translatory motion. Okay, I'll do one thing. I will displace this object. Look at that object, no? It got displaced, no? The point B is here and the point A is here. What will happen to RB bar? This is at t equal to 0. After some time, it is available here. So what will happen to new RB bar? Position of the point B. So RB bar is a position vector. The position vector of the point B and A are going to change. So I'll differentiate this. VB bar minus VA bar is equal to VBA bar, or VB equal to VA bar plus VBA bar. What are VA bar and VB bar? Velocity of the points A and B with respect to the origin, or shall I call absolute velocities? And what do you mean by VBA bar? Velocity of B with respect to E. And now, what do you mean by translative motion? Here, the translative motion is such that dRBA bar by dt will be 0. Means the distance between any 2 points will not change. Similarly, VBA bar will be 0. So what is the basic idea of translative motion? No? I just give an example rather than saying only definition. The body will undergo translative motion means, are you saying that just moving along x-axis is time being, you can think it in that way only. The position vector of B and A will change. So velocity of B and A will get it. Now, if you look at this particular velocity of B with respect to A will be 0. So the distance between the 2 points of a rigid body will not change. So how much it was earlier, it will be RBA only. So you try to see this. So shall we make now a basic definition? I'll write sentences. I'll explain here. This type of motion occurs when a line in the body remains parallel to its original orientation throughout the motion. Is that okay? No. So look at the line AB. It was vertical. So as the body moves, what happens? Still that particular orientation of that line AB, it will remain constant throughout the motion. Now look at this one. It was making some angle theta here. So that orientation will remain as it is. Then such a motion is called a translative. See, it's very important. We must know how to identify translative motion. So this is called like a translative motion. Now, one more thing. Translative motion can also be like this. Suppose say this object. There's a distance between the points. Again, you check it. Now, is it a translative motion? There's a path. There's a point A, B. This is A, B. This is a curvilinear translative motion. I'll give a few more examples. So what is this? This example of okay, fine. So now we'll go for the next one. I'll give one more example. No? It will be easy for you. So what do you mean by curvilinear translative motion? Now, if each point moves in parallel curves if each point moves in parallel curves and orientation of any and orientation and orientation of line AB does not change. So not only one, not only this. So how the path of all this will be parallel. I'll bring one few more points here. It will be. So I'll is that okay? Look at all these lines, how they are parallel. No? So the orientation of that line should not change, but it can move in a curve. This is called curvilinear. So I'll give one more example. Like this will be if there's a rod. Don't get confused this with rotational motion. It's still called as curvilinear motion only. This is curvilinear translatory motion. It is called as. So you look at the point A, B, C. So what happens? The distance and anywhere you take it is going to remain same. Curvilinear translatory motion. So the if you just draw a line, so everywhere what means the orientation of line should not change here. Okay, don't get confused. This is not a curved motion. It's a curvilinear translatory motion. So like this, what happened? We define a translatory motion. So what will happen to in translatory motion? The distance between any 2 points will remain constant, simplest way. And they should move in a straight line. Need not. They can move in a curved path also. Okay, this is about the first curvilinear difference. So next we'll go for the pure rotation. Already you know circular motion. Instead of here, motion of a particle, we are going to describe the motion of a rigid body.